My name is Jay Stapleton. I've been working on networks since that meant soldering, crimping, remembering where I put the 50 ohm terminators. When I was young and spry, I would be the one in crawl spaces and plenums running cables. I was in IT and operations for a while, and I'm now a solutions engineer with Tailscale, where we build tools to simplify network administration. When I was a lad, times were simpler. When the network was something you built, and IP addresses were abundant and cheap. Networking was about facilitating communications. When we wanted to connect computers together, it would look something like this. Every machine was physically connected to the other devices it needed to communicate with. And then, maybe in some cases, there was a gateway device to something resembling the internet. For the most part, we're talking about a local area network. The internet did exist in some primitive form way back then. It looked a little more like this. You could go for a round and find cool text files, then search engines came along. Eventually, you could play a game of Duke Nukem 3D with your friends, and the web became 2.0 and brought multimedia to us. Eventually, conversations moved to connected devices, Internet of Things, and with that, possibly exhausting IP addresses. That's okay, because we had this new technology which would rise to ubiquity and save the world. IPv6. Originally, there were obviously enough IP addresses to go around, since surely not everybody in the world needs a computer. There wasn't a concept that my thermostat would need an IP address, or a refrigerator, or a car, or even a telephone. 4.3 billion devices probably seem like a really big number. But don't worry, because we had IPv6 and the adaptation curve is up and to the right and would save us all, unless you kind of zoom in where it flattened out at about 35% adoption. Sidebar, if you're a fan of IPv6, and this is one of the few audiences where that might not be a ridiculous statement to make, so if you're a fan of IPv6, then overlay networks might be the best way to improve the adoption. Having a dual stack network out of the box brings IPv6 availability closer to ubiquity. Build the infrastructure and the applications will follow. Since IPv6 wasn't going to swoop in and save us, the humans of the networks needed to build out techniques to preserve what was rapidly becoming a scarce resource: publicly routable IPv4 addresses. And everywhere you look, there's another layer of abstraction. NAT is the big one. It means that every device in a building can share an IPv4 address. My thermostat doesn't need an address on the internet. CGNAT meant that my whole 5G carrier network can work through a small pool of addresses. And double NAT adds some recursion to the mix. Add virtualization, containerization, VPCs and CNIs, add another layer to the mix. These abstractions really start to pile up. Remember that above the cable, none of this is inherent. These are things that we've invented to make our lives easier. But we know that customizing any routing in these environments is complex at best and sometimes impossible. NAT has its own purposes beyond IPv4 preservation. I remember the first time I got masquerading working on my Linux device, I could dial into the internet and share that connection with all of the gizmos in my house. It offered some slight security layer as far as external actors initiating connections to internal devices, but that was more of a side effect of sharing internet connections and resources. Once you start having NAT as the default connection, we've lost some of the initial assumptions around TCP/IP networks. Connection timeouts and resets are a side effect of needing to keep that NAT table cleaned up. Then you'll also need to manage the exceptions. These exceptions start piling up, and managing them is usually a manual process. The abstractions that we've built are now working against us, and I believe it's time for a new dawn of network administration, a new way of working with networks. And mostly I'm talking about your business and corporate network. Though home lab networks can be even more bespoke and unusual than most corporate networks, home labbers get up to some interesting things. A new way is needed to peel back those layers of abstraction and get us back to a state where we can be more productive. And the solution to all this abstraction, in my opinion, is obviously going to be more abstraction. On top of all these layers, which at this point are needed to make modern network architecture work, we can just kind of paint over it. And for day-to-day administrative tasks, start with a blank slate with an overlay network that abstracts away the abstractions and brings us back to a network that looks more like this. Once we're back at this level and we can effectively ignore the mess going on, we can manage things at a scale where humans can make sense of it. As networks become more complex, our ability to secure them becomes more difficult. Having your data plane in this simpler architecture gives us back some control over how we do it. With tools like Tailscale, these mesh overlay networks, they also let you reshape the network via policy. So if you decide that these two machines don't need to talk to each other, then you can remove the permissions for that to happen, and the machines are no longer connected through the mesh. Now, we're in a state where the network doesn't have to look the same to every device. We have a perspective network. From a high level, this can look like a mesh with some links missing. But from the device's perspective, it sees itself on a flat network with its peers. Policy-based segmentation permits us to enforce security rules on the connectivity layer. This also gives us the opportunity to bring modern concepts right down to this network connection level. Identity-based authorization means that we can make decisions on access based on who you are, rather than just where you are. It can eliminate the implicit trust of you're here, therefore you can connect. Having your network connections tied to an identity from your SSO provider also means that you can bring MFA to legacy systems. A mainframe running legacy code can be accessed from anywhere securely. All of these links are authenticated and encrypted. The ability to control connections through policy means that you can adjust what connection is available and when that connection is available. This includes setting policies based on just-in-time access requirements. Policies could also be dependent on device postures, geographical location, or on metrics read in from other programs like an EDR or MDM tools. The flexibility of policies can bring a modern zero-trust security approach, which is consistent between legacy systems and modern environments. These network connections are now also consistent across environments. Servers, workstations, phones, containers, Kubernetes clusters, and Raspberry Pis are all able to be addressed in the connection policies. All of them with comprehensive network flow logging, selective software-defined routing, and identity-based access controls. The network is now a fully distributed and decentralized system that we can treat like a LAN, but behaves like the internet. More so, it behaves like the internet was intended to. We have this huge array of services and tools and products and networks, providers and platforms that facilitate a lot of what we have to do, but managing that all together is increasingly difficult. But with a little more deliberately applied abstraction, we can get back to networks that look like this, designed to be administered by humans. And this can undo a lot of the problems that emerge from our responses to the problems that emerge from the initial assumptions as the internet was being built out. And maybe once again, we can all live in simpler times. Thank you. I'm Jay from Tailscale.